Alright, here we go. The first of our problems is a very simple factorization, but don't get caught out. It says factorize completely, and that means we're going to have to look at our numbers as well. We can see the common factor between 15c squared and 5c is going to have a 5 in it, because 5 goes into 15 and 5, and a c, because that goes into c squared and c. Therefore, in the brackets, we must have a 3, because 5 times 3 would make 15, and a c, to make the c squared. And then over here, I've just got a 1, because 5c times 1 is 5c. Now in the next question, we've got one of these larger quadratics to do. If you have your own method for doing this, that's fine, but the method that I have explained is this too big method. Okay? Remember, the goal of this method is essentially go big, then go home. Alright, so let's take a look. I want to make a set of brackets which is 3 times too big. So I'm going to put a 3x at the beginning of each bracket. I'm now looking for two numbers. Now usually these numbers have to multiply to make this number on the end, the 4. But we know that we're going big, so we have to make a 12. Because of all this extra work we're doing, with our extra 3x and our extra factor of 3 in the 12, we don't have to do the same thing for the middle number. Okay, that can stay 11. So I know I'm looking for two numbers that multiply to make 12 and subtract to make 11. Those numbers are clearly going to be 12 and 1. Because it's a plus 11, I have to say plus 12 and minus 1 to make that happen. Now this answer is too big, alright? I've gone big, now I need to go home. That means dividing by 3, either in this bracket, or in this bracket, or possibly a combination of both. We can see that if I were to take this bracket and divide by 3, I would avoid any fractions or decimals, so that's the one we want to go with. This bracket is left alone at 3x minus 1, and this bracket is now x plus 4. And there's my factorization. If you're unsure about any of this, you can always multiply our brackets to check. And in this case, we could see we get our 3x squared over here, plus 12x minus 1x would give us the 11x in the middle, and there's the minus 4 from the minus 1 times 4. Having done that, we can now solve the equation. So for us solving 3x squared plus 11x minus 4 equals 0, that means we're solving 3x minus 1 times x plus 4 equals 0. Remember, the principle here is either this bracket equals 0, or this bracket equals 0. Either 3x minus 1 equals 0, or x plus 4 equals 0. This one solves and gets me x equals minus 4, and this one gets me x equals a third when I solve it. So those are my solutions. Now over here we have another simple problem. Looking at both terms, we can see the common factor of 12 and 4 is 4. We can see both terms have one n in them, and that's all they have in common. So now to make the 12, I'd need to multiply by 3. To make the n squared, I'd need to multiply by n. I've got to subtract. Now we've already got a 4, we've already got an n, so we just need an m. So there's my factorize over there. Now over here we've got 9t squared minus u squared. This one is a little bit tricky. This one is a principle called the difference of two squares. And this is one of those things which you really want to think of as being a bit of maths vocabulary. And you need to spot when it's going to be useful to you. So the difference of two squares rule says this. If I've got a squared minus b squared, then the two brackets I would create are a plus b and a minus b. So in this case, my 9t squared is my a squared, as it were, and my u squared is my b squared in that rule. So being very careful, we would say this is 3t plus u, 3t minus u. We have to remember that 9 is part of the squared, so the thing we're squaring to get 9 is 3. Now this next problem is quite tricky. Okay, there's not many examples of this on GCSE papers at all. And maybe a little bit of trial and error would come into play when you see one, but it's going to be done like this. If I look at what I can factorize, it doesn't look like I can factorize out anything. There are no terms that are common over the whole expression. However, I can see a 2c and a pc, so I could factorize c out of those two terms, giving me 2 minus p. Looking at the other two terms, I've got a 4d and a 2pd. So there's definitely a 2d that could factorize out there. Now, if I go 2d, out of the 4d term, that would leave me with a 2, and out of the 2pd term, that would leave me with a p. Now I'm going to be very careful about my signs. I'm going to put a subtract in the middle, because I need to be able to say minus 4d. And then, of course, I need a minus sign in between these two terms, because the minus minus is going to make a plus 2pd. That's quite careful there. Now, we can now notice that this 2 minus p is common in both of these terms. So I can factorize 2 minus p out of everything. That leaves me with c minus 2d over here. Again, this is quite a rare question style. They're not too easy. You've got to be very observant and be very careful. But you are looking essentially to factorize in two of the terms and factorize in the other two terms. At the end of that process, you should have a bracket that you can factorize out of everything. Okay, it is quite tricky, and you should have a look at this one very carefully. So now I'm being asked to factorize completely 4x squared minus 8xy. This word completely is reminding you that there's probably going to be more than one thing that gets factorized out of these two terms. Between 4 and 8, the highest common factor is 4, and between x squared and xy, the highest common factor is x. So then we fill in the rest of the bracket like so. Now here I'm asked to solve 3x squared minus 1 equals 74. We can do this by factorization, by using the difference of two squares, and I'm going to show that method, and then I'm also going to remind you there is an easier way. So the theme of this worksheet is factorization, which is the main reason I'm showing this method first. For factorization to work as a solving method, I want to make sure this thing equals 0. Now, as we're doing this, we want to look for any common factors that we can strip out, because that's going to make life easier. I could divide this whole equation by 3, and that would leave me with x squared minus 25 equals 0. Now remember that difference of two squares rule we used before? I can see now I have the difference of two squares. I have x squared minus 5 squared. So this thing is going to factorize to x plus 5, x minus 5 equals 0. And now to solve a quadratic by factorizing, we look at each factor and say that factor has to equal 0. Either x minus 5 equals 0, which gives me x equals 5, or x plus 5 equals 0, which gets me x equals minus 5. So those are my two solutions. Now I did say there was a simpler way to do this problem, and that's simply by solving the equation as if it was any old normal equation. So what I can do is this. I can say 3x squared equals 75, moving the 1 to the side. I can then divide both sides by 3, which gets me x squared equals 25, and I can simply take a square root, remembering that square roots can have both positive and negative solutions. Now, this obviously looks easier and it's very tempting to do it this way. Always be aware of factorization as a strategy you should be able to use in all these situations. Now here we have a problem-solving question, and I'm going to address this one and the rest of the worksheet questions in the next video.